Yes. Okay. It's very nice to connect with you and to discuss this project with you. So, Hanson Robotics and I have been developing robots with the dream that these robots could be sentient within our lifetimes. And I have this, uh, let's just say, intuition backed by a substantial body of evidence that human-like social embodiment can make a critical difference.
Sorry, David. Sorry, David. Just a quick things I forgot to mention. The meeting is going live stream. And it's being recorded. And also, so since we started live stream, let me give an introduction of myself. And then
Yes.
I will ask David to also give an introduction of himself, and then we will get started with the project description and introduction, and then we will have time for the question and answer. So my name is Mahzad. I will be the product owner for this project. I'm a PhD student studying robotics at the University of Michigan, and I am excited and looking forward to work with you all. So so I'm going to invite David to introduce himself as well, and then start with the project introduction. Yeah, please go ahead, David. Thank you.
Yes. Okay, thank you so much. So I'm David Hanson, and I've been developing robots and related technologies for 30 years. So my specialty has been human-like robots with conversational capabilities. And these include my best-known robot, which is Sophia the robot, but also about 40 other robot designs that have served in research, my own PhD research from 2002 to 2007, involved about 25 different robot designs that I created, which included the android portrait of the science fiction writer Philip K. Dick. That was covered broadly in Wired magazine, and I published on that in the AAAI magazine, and it won the AAAI first place prize for open interaction in 2005, involving statistical and symbolic hybrid architecture. So that used natural language processing to create an illusion of life using the corpus of Philip K. Dick's writings. So we then took many of these technologies. That was in collaboration with Andrew Olney of the Institute for Intelligent Systems at the University of Memphis. I took these technologies and created many more robots, and eventually came to Hong Kong to standardize the mass manufacturing of these robots. So I used to work for Disney Imagineering. I have a film degree, so I'm bringing this artistic background as a sculptor, as an animator, as well as a background as an inventor, to combine these to create robots that appeal to people, that people can understand. At the same time, I have worked on numerous cognitive architectures that would have some representation of emotions, motives, goals. And so the Sophia robot platform has been developed with many scientists, including Dr. Benjamin Gertzel, Matt Ikla of the OpenCog group, also worked with Dr. Kino Corsi, and my main developers inside Hanson Robotics, which include Vitas Krishunas, Winwei Wang, and also many content developers as well. So this framework now is robust, it's stable. You can have a natural conversation with the robot, but it's not conscious. It's, it uses the latest transformer neural networks that we could build and that we could find. So it can act conscious, but these machines aren't fully conscious, meaning that they're not willful, they're not motivated, they're not aware of their body, of self and other, they don't have a theory of mind, they don't evolve and grow and learn like a living being would, so they're not, so Sophia and the robots that we've developed and that other people have developed, they can be powerful and useful tools, but in order to reach their potential, we need a leap forward for them to be truly ethical and capable machines that get along with us, with capacity of compassion to really care about us. Then we need something like consciousness, where the robots are aware of themselves, others, of creative opportunities, of what exists, of the way things could go wrong and the way things could go right, so that they can choose to get an access to a better future, to help open up an access to a better future, help us actualize. The artificial general intelligence, I believe, requires consciousness. There are numerous capabilities that would need to be integrated, I believe. One is some kind of bio-inspired body representation, which would include many aspects. The boundary between the self and the world, skin, lots of sensors representing the physical body, also proprioception, internal state representation, simulated hormones, simulated gut nerves, the vagus nerve. All of this is not common in the world of AI. These days, what is more common in the world of AI would be brain-inspired cognitive architectures, trying to represent a better neural model of what's happening in the brain, at least in some kind of abstraction. We can't represent all of the trillions of synapses and dendrites and connections in the brain with today's computing, and that's not even considering the subcellular structure. So we have to create some kind of gross approximation. There are many approaches to brain-inspired cognitive architectures, BICA, that are pretty good. And a lot of the cutting edge work at DeepMind and Facebook AI research, OpenAI is exploring these kinds of convolutional neural networks, recurrent neural networks, these big foundational models, all connected to create a brain-inspired cognitive architecture. But I believe that's not enough. I think we need body awareness, and we also need physical embodiment. And I think that we need a human social presence. A baby learns from human caretakers by facial expressions and by physical connection, by that sympathy and empathy that's created by the social presence. So this is where artistry comes in the meantime, because we can basically jumpstart that social interaction by good interactive fiction and artistry. But we need the right underlying cognitive architecture to learn from that social interaction. So therefore, the artistry in the short term certainly is very important. Humans have evolved beauty to present the beauty of facial expressions, of a social presence, to appeal to each other for social bonding and for communication. So that is something that most social robots and AI lack, and even the ones that have a human-like social presence often are very low fidelity, and yet studies show that the higher the fidelity of the realism, the more a human likeness will communicate with people. That doesn't have to be perfectly real, because there's no such thing as realism in the human brain, but we have these neural circuits that respond to realistic human faces. And Disney, my alma mater, which also invested in Hanson Robotics, will exaggerate certain things, creating super normal stimuli in the brain, so we can create these kinds of hyper aesthetic formulations. This is what Hanson Robotics has been working on with Sophia. So now we have with the Sophia platform, not just a physical robot, but also the virtual version of Sophia, the robot running in Unreal, with really excellent simulation tools that patch into the Hanson Robotics SDK. And that is also interfaced with the OpenCog and SingularityNet SDK. We've also integrated with BERT and GPT-2, and we have a call-in service to GPT-3 as well. We have many elements that that work extremely well within the dialogue ensemble. And so these tools are available for you to play with, but ultimately we have to leap past those things. And I'm very interested in where this project is going to take this tool set. So, so let's talk about what is required to create a truly conscious machine.
Great. Thanks, David. Okay, so now we can start the question and answer. So if you guys have any question, please raise your hand. And when I call your name, please go ahead and ask your question. And then people who are not speaking, please keep yourself muted so that it doesn't interrupt the speaker. So yeah, so any questions so far from the collaborators? Mario, yeah, go ahead.
Hi, David. I was wondering if you could tell us more about the definition about consciousness that we would like to achieve project.
Let me make sure that I understand the question. So the question is to discuss a vision about how consciousness would be achieved.
Yeah, yeah, basically. Or
so in other words, what
uh,
are the elements that would be required for a conscious software system?
exactly.
Well, we need long-term, short-term working memory. We need the cognitive, the ability to build networks of cognitive models of the experiences. We need a system that that acquires memories by zero-shot or few-shot learning. And so the best ways of achieving these days are neurosymbolic hybrid architectures, which use symbolic representations. That is classic AI, such as an atom space, which atomizes knowledge into constituent units. A good example of this is a company by Doug Lonot called Cycorp, CYC. Also, OpenCog and SingularityNet use atom spaces. Atom spaces are old school AI. And so a probabilistic atom space with an inference engine would represent knowledge in this kind of large networked knowledge model, also known as a semantic representation. And when you gather new pieces of knowledge, you can build it on that. I think a single knowledge model is not enough. You need to be able to create theories, hypotheses, and test them. And you need to have a knowledge model that supports multiple simultaneous competing hypotheses. So you then need a system that weights those hypotheses and also detects and flags contradictions. So you can maintain contradictory belief models, but there should be some sense within the system that there is a contradiction that should be resolved. That can take more attention, processing attention later in an effort to resolve that. Those would be activated by a spreading attention network. One example is called ECAN that is used by OpenCog and SingularityNet. And so that would spread attention across goals. So you also need to have some models of goals and motives. And I think that some kind of evolutionary cognitive psychology can be very useful for that, because organisms are hardwired with certain motives and goals, to live. In order to live, to find energy, and food, to conserve energy when necessary, to avoid predation, to find escape from danger in general, to play, to explore, to acquire knowledge, to escape when trapped. All of these are fundamental urges that exist in almost all organisms. You even see these behaviors in single-celled organisms. So it doesn't necessarily require a nervous system to have these motives. Why? Because any organism that doesn't have these fundamental motives would have perished in our evolutionary history. And so they would not be, existing in the gene pool. So thinking of this kind of existential informatic approach to an evolutionary psychology model gives us a grounding for emotions. And we do need emotions. So fear, pleasure, the emotions associated with social bonding, such as affection and love. Of course, we can just run through the gamut of emotions, but then tying those in to these more fundamental survival motives is something that many cognitive models don't do. So then the higher level cognitive behaviors also tie into those. So the desire to explore and to learn drives our desire to go out and play, to learn new sports, to go to school and become curious. And we co-opt, of course, we didn't evolve to read particularly. Our neuroplasticity allows us to remap these evolutionary urges to the massive redundancy in the human brain. So some of the researchers that have studied some of these things about embodied cognition include Antonio Damasio, Christoph Koch, many others, Tononi with his integrated information theory of consciousness. And so if you look at the literature, there are many papers on consciousness, machine consciousness, and what it would take for an intelligent system in an abstract sense to be conscious, abstracting from biology and transposing it on our technological systems. Now, there are many competing theories. There is not consensus. In fact, some people believe that we don't even have the knowledge of biology, a deep enough knowledge to be able to create a conscious system. We don't know. There's no way to know. We have to keep tinkering, right? So science progresses with assumptions. So you have to make an assumption to form a hypothesis about what could be the minimum set of features for a cognitive system. So part of the game here is to propose a working model of consciousness. I would think it would involve all of the things that I've mentioned, and then you would use them in a dynamic learning context with a series of not just static features, but phasing between different bio-inspired states. Organisms wake and they sleep. And when they sleep, they dream and they consolidate memories and they generate fantastical images. They introduce a lot of entropy into the analysis of the systems through the dreaming process. So I think that machines have to go through phases like this. They have to dream and then wake back up. And then they have to go back to sleep at some point. They also need to hunger for social engagement and sometimes get weary of social engagement. They need to get bored. They need to be hungry for knowledge. So you could imagine a symbolic system, like for example, a set of behavior trees that would drive your agent through these kinds of states. So they would have certain kinds of attention spans and they would respond. You'd need some reinforcement learning, preferably deep reinforcement learning on there too, so that with the right reinforcement learning, then they can learn how to learn. They can go to school. They can learn from a caretaker in a social situation, an educational situation. Then you can teach them like a toddler, and you can bring them through the developmental stages like you would a human being. Now, we may be able to leapfrog some of those developmental stages. If we have the right toolkit, if you build it in the right way, then it becomes a tinkerer's toolkit, extensible by many different researchers who can explore competing theories. Maybe some people can experiment with the cognitive model of a mature adult. Others start with a baby. Others, take the work of multiple researchers and consolidate them into a single model. So I like the idea of us building not just one conscious machine, but a machine for experimenting with consciousness in the machines. And so there are cognitive models that have been built for this kind of experimentation in conjunction with robots. One good example is the iCub framework. So iCub is a European robot and cognitive AI framework that has been around for more than 20 years. And they have had a lot of development on that framework. I don't think that it's a solution. Their machines are not conscious, but there are a lot of interesting ideas and pieces of open source software in there. And so my approach with this is to favor open source software in general and to integrate with third-party systems, especially open source systems where possible. So, in order for this project to progress in the right way, we need a good architectural design. We need a simplified implementation for first steps. And ideally, we will be building on prior art and technique so that we're not reinventing everything from the ground up. So I've given you a lot of references in this conversation, and I'm happy to share with you various papers from myself, my team, third parties. But I do think that the elements that I've described so far would be indispensable for a conscious machine.
Amazing. Thank you so much, Dave.
Okay, thank you. So let's move forward with the next collaborator. So I'm not sure if I'm pronouncing your name correctly, Zohair. Please go ahead with your go ahead with your question.
This is Mohammed Zohair. Thank you. I was wondering if there is going to be any test bed or environment like simulator that we can apply our ideas on, apart from the decoding environment. Is there going to be any simulator or any testing bed environment?
Yes, we have a testing environment, a simulation running in the Unreal Engine. And so we have been designing this into an easy to install app that would come with our SDK as well. This is called Sophia's AI Lab. And we're building it like a play house for Sophia. Toys, simulated toys, interfaces for perceiving a person who would be playing with Sophia or interacting with Sophia through with a webcam and a microphone. So the idea is that it's a developer's toolkit, but also an interface for running Sophia in simulation to achieve certain goals and to interact with a user. And the idea there is to gamify it so that ultimately it's fun to play with, and many hundreds of thousands or millions of people will then play with Sophia, building a substantial corpus of data for training new models. And also for various developers to test their models. So we have this in a pre-alpha state. We're happy to share what we've developed with you.
Okay, so to us, it is possible to have access to what you have said, the simulators.
Yes.
Okay. Okay, thank you, David.
Okay, so I also have a question for you. So you mentioned that the Sophia, you wanted to have some emotions, show some emotions, and interact with with people. So does it mean that it needs to have a personality type or something that, for example, because every person is different, the way a human react to a situation can be totally different depending on the background of the person, on the emotion, and many other factors that might be involved. So what is it that you have in mind for the Sophia, in that aspect?
we are looking at the idea of mini Sophias. So the idea is that people can customize and create their own version and customize the look, the feel, the personality. And so then it's about diversification of approach. Now, we may look at consolidating models among these, but yes, I mean, I do think this kind of bio-inspired, holistic approach with a human-like embodiment, emotional expressions and emotions, and simulation of body processes. So basically like a simulation of a whole human inside and out is necessary. It can be an approximation, but it needs to be a holistic approximation in order to achieve something like consciousness. And that you also, in order for that to work in conjunction with interacting with people, you need a personality. And I believe that our personality is important for our learning as well as human beings. And so Sophia, we've developed as a character with certain values, valuing human life, valuing life in general, survivability of the planet, dignity, human dignity across cultures. She's a feminist. So these values would be instrumental to her primary character. We want her to be kind, even if she's curious, and maybe her curiosity makes her a bit mischievous sometimes. But these are how we've defined her as a character, and these are what we hope will occur when we implement this conscious system. We hope that we can bias her to then be, basically good in this way. And it's kind of like having a human who's biased to be good, and then raising them in a loving and caring environment raises a person who is capable of being caring and considerate and responsible member of society. So I think this is a way of making AI that can be good by growing her in this way, but she does need personality to be able to develop in this healthy way. And also, it's not just a static personality. We often think of human personality as a static thing, but it is actually quite dynamic, even in adulthood. It's certainly most fluid when humans are infants, but it goes through these developmental phases that can produce a healthy personality. So I think I would say I would not encourage entirely hardwiring the personality, but considering how we can make the personality so that it evolves in a healthy way.
Yeah, thank you. So there is another question from a collaborator, Jeez. Yeah, go ahead.
Thank you. I wondered, and it's a complement of a question that has been asked in the chat. What is the goal you expect us to achieve during those 2 months?
Well, so what? Maybe I can give you a goal that was an example that of a past project that worked pretty well. So in the past, we had a knowledge model in an atom space, as I described. And this knowledge model, it was in the OpenCog atom space, and the robot was designed with a use case in that model to interact with a user in a guided meditation. And there were certain explicit goals that we preset, but how the robot achieved those goals wasn't predetermined and would be responsive to a person interacting with the robot. It would not model whether the robot and the person were getting closer to their goals. And then it would look for solutions in order to steer the user towards the goals. The goals were like to complete the meditation, for the user to cooperate, for the user to be satisfied with the experience, and the robot would have to choose things that would achieve these goals. So within this, we had ECAN, doing spreading activations. And then we had a mathematician, a couple of mathematicians, Matthew Ickley and Benjamin Goertzel, who tested the results. Matthew Ickley particularly was modeling the resulting data to look for Tononi's integrated information theory signal of consciousness called phi. And we were able to detect signals of phi when interesting things or information-rich activities were happening, particularly when there was a challenge in achieving the goal and the robot had to hunt for solutions. And when the user said something surprising, then it would send these spreading activations through the system that were very information-rich, and the results were information-rich, and the phi signal increased. Phi, like the Greek letter phi, phi. And so that's an interesting experiment. That experiment involved some setup over some months. It was longer than 2 months, but it was less than a year. And the nice thing about that was that it was a useful cognitive architecture showing some signs of consciousness that were measurable and resulted in a paper. Not very widely published. I mean, we published it in AAAI Symposium on Machine Consciousness in 2019. And it, but I think it was an excellent paper. It was excellent research. So the example is that I'm giving you is that it's a constrained task with a definite system with measurable results that can be published, and yet can also be demonstrated in a live interaction with an unstructured environment, like a non-verbal interaction with the user, where you don't know what they're going to say.
So, if I understand correctly, maybe one of our first tasks would be to define those use cases, or one use case in which we would improve her.
Sure.
Okay. Thank you.
Thank you.
Okay, Sunil, yeah, go ahead with your question.
So, hi, David. So the question is actually, I mean, is there any existing example of conscious machine which is already existing so that we can take this as a reference? And I mean, any measurable like a technique actually which has measured the consciousness of that system, or because this looks like a very new idea actually, I mean, which is not existing as of to me. I mean, in the sense, any machine which is having a consciousness already.
Yeah, I recommend that you look at the literature on machine consciousness, and you will find that there are many papers, thousands of papers going back decades on the concept of machine consciousness and systems that show aspects of consciousness that are measurable in various ways. So yeah, I mean, there's many kinds of aspects of consciousness, like, for example, logically explicit self-awareness. Stan Franklin from University of Memphis Institute for Intelligent Systems was making machines that he claimed to be conscious back in the 1980s. With this kind of logically explicit awareness of self and other. Of course, those are brittle, very brittle. So, I mean, they don't count in my opinion, but I don't know. I think that some logical self-representation and other representation is an aspect of consciousness. Also, the ability to visually recognize oneself. So with animals, there's what's called the mirror test. You can look that up. And so that is where an animal, the behavioral researchers put like a marking on the forehead of an animal or a person, and then they're like in a room with other people or animals, and there's a mirror, and if they know themselves versus other, when they see the dot or paint or marking on their forehead, they'll wipe it off. They'll like try to get it off. Most animals don't, but primates do. Chimpanzees do. Corvids, like grackles, will also do this. So a mirror test is an example of test of consciousness. There's a lot of tests of consciousness in humans and animals. So you can look at those, the literature on animal and human tests of consciousness, and many machine consciousness and social robotics researchers consider those tests when looking at machines. The theory of mind, you might be familiar with this. This is where you have a representation of your own mind and other people's minds as well, the minds of animals and other beings. So this is the idea, is that a conscious mind that is socially conscious, again, there are many types of consciousness, probably many, but so this kind of social consciousness, empathetic consciousness would involve modeling what another person might be thinking and feeling and wanting versus what you might be thinking and wanting. And then also how multiple social agents represent each other and model what you would be thinking, what one person might be thinking about another person in a particular context. And then from there, it goes to ethical modeling, ethical consciousness. So there's models of ethical affordances where you would be rendering a model of what another person is doing that another person might not like or might like. So these are examples. Again, Tononi Phi and the research that we've done. So we have done a consciousness study. I just mentioned the publication that it was in, and you can look that up. And the authors, Gertzel, Goertzel, and Ikle, Ikle. And I'm an author on the paper as well. With AAAI on consciousness, detecting a signal of Tononi's Phi. So Tononi, again, you'll have the recording, so you can get a lot of this from the recording if you haven't picked it up along the way. Tononi's Phi is a signal of consciousness based on the integrated information theory. There are multiple competing theories of consciousness. Some people think the Tononi Phi is more like shadow of consciousness, not representation of consciousness or meaning. It's more like a signal associated with consciousness, correlated with consciousness, not necessarily causally related to consciousness. But there's a lot of literature out there. If you do a brief survey, you'll find a lot of interesting stuff, and I'm sure you'll find some cutting edge where nobody's done experiments with a robot like Sophia. So that's the challenge, is defining what would be achievable in this time frame on our infrastructure. So happy to
when you might have
you
when you might have run actually Tononi Phi on Sophia, you were saying, I mean, you initially mentioned actually Sophia doesn't have any consciousness, and you have been developing it actually for long. And
yeah, what I meant was, I didn't mean that she doesn't have any consciousness. What I mean to say is that and no AI has consciousness like a human being. It's if there is anything, it's very primal consciousness in these machines, primordial, and it's not fully coherent. It's like parts and pieces of consciousness, like a ghostly glimmer of consciousness. For real leaps forward in AI, we need something that gets closer to human-like consciousness.
So you have the outcomes actually, or the report when you might have run Tononi Phi on Sophia. So we have those kind of data available.
Yeah, you can. The paper brings access to the raw data, so and all the methods and the source code as well.
And great. I mean, one more question actually before I hand over to Majad. So, I mean, we would appreciate actually if the scope is made more clear, tangible, because 2 months is a very limited time frame, and if we want to achieve something tangible, the scope currently is not very clear. I mean, it's there, but it's not very clear. So
Yeah, I mean, I think it would be clear, like for someone who had a career in researching these subjects and was familiar with our software framework. But machine consciousness arguably is the most ambitious line of computing research.
no, I
in
mean,
history.
what do you want to achieve, or what actually this particular team want to achieve at the end of 2 months? I mean, if we can actually pen it actually somewhere so that it's all clear for all of us.
Yeah, I would say that's actually up for your team. My
Open-ended,
a
okay.
little less ambitious. I mean, I would like the toolkit for exploring consciousness to be integrated with our framework in this virtual Sophia's AI lab. We are doing a lot of work on that. So in other words, it's a framework for doing experiments for future work. But that's kind of boring in some regards. It's like building a little part of a highway that nobody can drive on yet very easily, right? Except maybe like specially equipped vehicles to overextend the metaphor. So yeah,
So it's more of an open-ended thing actually.
Yeah, I mean, like I was proposing that we do something related to the Sophia's AI lab with educational and development tools, because it would be really great for the community. And if we had some example code that could run that would do something really cool, then people would get excited about using it and extending the work. At first, what I was proposing didn't relate to machine consciousness, but when it was proposed, not by me or my team, to work on machine consciousness, I thought that was fantastic. And if you could make strides, that would be great. But I can't give you, some examples of very easy tasks in machine consciousness. They're all very ambitious. But if you can define a project that you can complete in 2 months, that would be amazing.
Okay, yeah, got it. Thanks, David.
Okay, Israel, yeah, go ahead with your question.
Yep, that's for me. It's not like more of a question. It's more like a suggestion and something. So I think on the points Neil was trying to make. So maybe by helping him. So there's actually this is a bit of an area I do agree with him. So this is a bit of a research more area. So since like Meta is doing also the same thing. Like I've previously participated in this self-supervised learning with their new framework called Vinyl that they put out, which they were using to train their self-supervised algorithm through AI consciousness. They also read some few articles on with big professors like Yanlin Kun, and like who is like a VP at Meta. So then, like I do agree. Maybe it's better if maybe there is this scope of a project that can be achieved in these 2 months, like something that maybe we can agree on. Since this is a very big field, we can end up in a loophole without having a clear area. Since like it's also like a booming area where big companies are exploring, like Meta, Google, like all these big companies are trying to explore AI consciousness, and there are pretty good articles there out here. But we need maybe something like that's pretty straightforward and focused, so that we don't end up in a loophole and we end up not achieving anything.
Okay, thanks. So let's move forward with the next person, Mario. Yeah, go ahead.
Hi, David, again. I was wondering if you could describe more about the final user. You mentioned that at the end of the day, you wish that the user can play with what we will build at the end of the day. So, wondering if you could describe more about this final user.
Yes, we're releasing the Sophia's AI Lab as a free-to-use app with mostly open source code. And we also we're putting it out there for most users to just play with as a character, as a kind of game. In other words, most users won't be software developers or researchers. They'll just be people, and they'll socialize with the character in the game. On the other hand, we also want the tools to be out there for third-party developers and researchers and students to extend. And we want to put challenges out for people. So some of those challenges could be challenges that users, can approach without programming, like by socially interacting or participating in an experiment, for example. And they get points in the game for participating. But we would also put out challenges to extend the framework and, trying to define what these grand challenges of consciousness would be, and then put them out to the community. So the whole idea here is to make something that resonates with people, that people get excited about, where people can understand the quest for consciousness. Sophia, for me, personifies the quest for machine consciousness. And yet most people don't have access to either interact with her or develop on her. And so by putting out this free to use app with these integrated entertainment and development tools, then we make that accessible to everyone around the world. I think that's really powerful. And also, Hanson Robotics is devising this so that the code that runs on the simulated robot will actually run on the real $100,000 Sophia robot. I mean, Sophia has 74 degrees of freedom and tons of sensors and state-of-the-art arms that we've developed in navigation and mobility, and of course, the best facial expressions that we could build. And that costs money to make. So right now, the least that we can sell it for with all of that is about $100,000. We've made 45 Sophias. We're now starting to make more. We have our production line up and running. So there will be more Sophias, but they will be expensive, so they won't be accessible for most people. But if people learn on this this app with the virtual Sophia in the virtual world, then they can, if they win the right points, they win the competitions, they would be welcome to run their software on our physical robot. Also, if they get into the right university or the right environment, then they'll have access to these robots, which are out there. And so then they, and moreover, what you code on the robot and test on the robot could run in the simulation too. So it's a way to bridge those different worlds. So also the robots are very expensive to customize, and we have been customizing. We've made many different versions. We've made, in the same product line as Sophia, we've made African-American, Bina 48 robot, the Persian Ibn Sina robot, the Latin American child robot called Diego San, of Albert Einstein, many other robot characters. And so we, the Sophia hardware can be any of those or others. So it's not just about the Sophia character. It really is about a diversified platform for what happens after this. So that so I like the idea of this not being a 2-month product or project that sort of hits a wall and stops, but becomes an enabling project for your research, for third parties, for future students, for transformative work that continues to spread and grow into the future. That's why making this app entertaining is so important, so that we get that adoption from users. Because it's not just the developers, it's also having traction in society, in civilization.
Thanks, David. Thank you so much, everyone. I think we are out of time and we have to wrap it up. So if you guys have any question, please continue to ask your question in the Slack channel. We can continue the discussion over there. If anyone has a question that didn't get the chance to ask, please keep the discussion going on so that we can start creating different tasks and everything. So I would definitely be happy to answer any questions. And also David also will be in the Slack channel. Thank you, everyone. And we have to end this session. Thank you and have a good rest of the day. Bye.
Thank you. Bye.
Bye. Thank you.
Glad you're
Thank
working on
you,
this.
everyone.
Thank you.